For centuries, sailors told terrifying stories of walls of water rising from nowhere, waves taller than buildings, moving faster than ships could escape. Scientists laughed, engineers dismissed them as exaggerations. Textbooks said such waves were statistically impossible, and for a long time, science refused to listen. Because according to the math, the ocean simply could not produce waves that large, not without hurricanes, earthquakes, or tsunamis. But the ocean didn't care about the math, and one day it proved everyone wrong. These are the giant waves scientists once refused to admit existed until the evidence became undeniable. Rogue waves, the walls of water. Rogue waves were once considered maritime myths. Sailors described waves twice or 3 times taller than surrounding seas, appearing suddenly and disappearing just as fast. For decades, oceanographers insisted these reports were either mismeasurements or panic-induced illusions. That changed in 1995. An offshore oil platform in the North Sea recorded a single wave measuring over 25 meters high, far larger than wave models allowed. This wave wasn't part of a storm surge or tsunami. It came out of normal-looking seas. Instruments confirmed it, cameras recorded it, and suddenly the impossible became real. Today, rogue waves are recognized as a result of wave interference, currents, and nonlinear energy focusing. They've been linked to countless ship disappearances once blamed on human error. The ocean had been producing monsters, and science just wasn't ready to see them. The Draupner Wave, the proof no one could ignore. The Draupner Wave wasn't just another big wave, it was the moment denial ended. On January 1st, 1995, the Draupner oil platform in the North Sea recorded a wave significantly higher than surrounding waves, measured with laser sensors and pressure gauges. Unlike sailor stories, this wave came with hard data. No eyewitness confusion, no exaggeration. What shocked scientists wasn't just its height, it was how suddenly it formed. Standard wave theory predicted such waves should occur once every several thousand years in a given location. Yet this one appeared during relatively typical storm conditions. The Draupner Wave forced researchers to rewrite ocean wave models. It proved that extreme waves weren't rare anomalies, they were natural outcomes of ocean physics. The ocean had been warning humanity for centuries. We just didn't have instruments sensitive enough to listen. Mega tsunami waves. The waves that rewrite coastlines. When people hear giant wave, they think tsunami. But mega tsunamis exist on an entirely different scale. Unlike earthquake tsunamis that spread across oceans, mega tsunamis are caused by massive landslides or collapses, entire mountains crashing into water. One of the most extreme examples occurred in Lituya Bay, Alaska, where a landslide triggered a wave that reached an astonishing 524 meters up a mountainside. For years, scientists doubted such heights were possible, but geological evidence was impossible to ignore. Stripped trees, scoured rock faces, and precise dating confirmed it happened. Mega tsunamis are rare, localized, and terrifyingly powerful. They don't cross oceans, they erase coastlines instantly, and they proved that water, under the right conditions, can behave in ways that completely defy human intuition. Why science got it wrong? The problem wasn't arrogance, it was incomplete data. Early wave models assumed oceans behaved smoothly and predictably. They underestimated how waves interact, combine energy, and amplify each other. Once satellite data, deep sea buoys, and advanced sensors came online, the truth emerged. The ocean is non-linear and chaotic. Waves don't just pass by each other. Sometimes they collide, merge, and explode upward into something monstrous. When ships vanished without a trace. For centuries, ships disappeared in calm seas with no distress calls, no debris fields, and no survivors. Investigations often blamed navigation errors, storms that never existed, or crew mistakes. But many of these incidents shared one disturbing pattern: weather conditions that didn't match the destruction. Entire cargo ships were found broken in half. Containers weighing tens of tons were ripped from decks as if they were toys. Bridges designed to withstand hurricanes were smashed by a single impact. For a long time, these incidents were written off as bad luck. Only after rogue waves were accepted did these mysteries begin to make sense. A single wave, twice or 3 times larger than surrounding seas, can strike with enormous kinetic force, far exceeding what ships were historically designed to handle. One unexpected impact is enough to cause catastrophic failure. Why rogue waves are so dangerous. What makes rogue waves deadly isn't just their height, it's their shape and speed. Unlike regular waves, rogue waves are often steep, almost vertical walls of water. They don't lift a ship gently. They slam into it, delivering a sudden force that structural designs never anticipated. The impact can shatter windows, flood engine rooms, and destabilize even the largest vessels in seconds. Modern simulations show that a rogue wave can exert pressures equivalent to a high-speed collision. And because they form suddenly, ships rarely have time to turn or brace. Crews see the wave only moments before impact, if they see it at all. In many cases, by the time instruments register the wave, it's already too late. Where these waves appear most often. Rogue waves don't form randomly everywhere. They're more likely in regions where strong currents meet opposing winds. Areas like the Agulhas Current near South Africa, the North Atlantic, and parts of the Southern Ocean are particularly dangerous. In these regions, ocean currents slow incoming waves, forcing energy to stack vertically instead of spreading out. This stacking effect dramatically increases wave height when combined with wave interference, where multiple waves align perfectly. The result can be a sudden towering wall of water. These locations have long been feared by sailors, even before science could explain why. Rogue waves versus storm waves. A common misconception is that rogue waves only occur during massive storms. In reality, they can appear in moderate or even calm conditions. Storm waves are chaotic but predictable. They rise and fall with wind patterns. Rogue waves, on the other hand, are statistical outliers. They can form within normal seas, towering over surrounding waves without warning. This unpredictability is what made scientists hesitant to accept them. Traditional wave models assumed randomness averaged out extremes. Rogue waves proved that the ocean doesn't average, it concentrates. Could even bigger waves exist? This is where things get uncomfortable. Scientists now acknowledge that rogue waves larger than anything recorded are theoretically possible. The ocean is vast, chaotic, and undermeasured. Many regions remain unmonitored, especially in the southern hemisphere. Climate change may also play a role. Changing wind patterns, stronger storms, and shifting currents could increase the likelihood of extreme wave formation in the future. In other words, the waves we've already seen may not be the largest the ocean can produce. The most unsettling lesson from these waves isn't their size. It's the reminder that nature doesn't need our approval to exist. The ocean was creating rogue waves, mega tsunamis, and impossible walls of water long before humans had equations to explain them. Science didn't discover these waves. It caught up to them. So the next time you hear a sailor's impossible story, remember this: the ocean has been right before and it will be again. If this fascinated you, hit like, subscribe, and comment below. Do you think there are still ocean phenomena science hasn't accepted yet? Because some waves don't just crash into ships, they crash into our understanding of reality.